is not going. Let's see. All right. Finally up. Just having some technical difficulties. All right. Finally up. Just having some technical difficulties. All right. Hokie dokie. So let's jump into it. So I just want to mention in the description there is a nice little Google Doc of stuff I was working out this morning. It basically just has a bunch of important formulas, so like derivative rules, some of the business formulas, profit, revenue, cost, a little bit about elasticity, and really those are the big ones in my opinion, just knowing or like being comfortable with derivatives and the basic profit revenue cost, and then just there's some other like tips in there, things to look for, how to approach certain problems. The biggest suggestion I have is always look towards like the last question or last sentence in a problem statement, and usually it's that kind of guides the process of what you're working out basically. So all right, let's see if we can jump into it. We're going to take y'all into my email, and we're going to look for questions that people have sent. And this is not it. I'm looking for in unread. Come on. Maybe that's it. There we go. Alrighty, so let's jump into it. Whoops, we're going to save this. We're going to go to this, and we're just going to try to start working it out. So hopefully I'm loud enough for you all to hear me. If I'm not, please let me know. If there's any difficulty hearing me or seeing me, this video will be available. It should be like saved to YouTube after this if you don't want to sit through this whole thing. But send any more problems to my email in the chat there. So let's get started here. So we are trying to simplify this expression here. It looks like a nightmare, but we're going to give it our best shot. So it uses a lot of exponent rules here. The first thing I'm going to do is distribute this 9 to the numerator and denominator exponents. So 9 times 1 over 5 is 9 over 5. And then x to the 4th times, the 4 times 9 would basically just give us x to the 36. So we have all this on top, and then we still have this square root of x cubed on the bottom, which I would go ahead and rewrite as x cubed, but then raised to the 1/2. So rewriting the square root as a 1/2 exponent. So then we want to try to simplify things if we can. Let's see. I'd probably start with just this numerator here. So what we're looking at right here. So we have x to the 9/5 over x to the 36. So we want to rewrite that as 9/5 minus 36 within one exponent. So when we're dividing two x values, different exponents, we subtract their exponents. So we're going to work this out first. So I'll probably just use Desmos or some kind of calculator for this. So real quick, 9/5 minus 36. And then as a fraction, negative 171 over 5. You could keep it as a decimal and then kind of work it out later. But in this case, we'll just use the fraction button. So we have basically this from everything we had in the numerator originally. So then we still have x to the 3 times 1/2 in the bottom. 3 times 1/2 should give us x to the 3/2. And then the very last step is, since these x values are divided by one another, we will subtract their exponents. So negative 171 over 5 minus 3 over 2. So we get negative 35.7 or negative 357 over 10. Which if we rewrote without any negative exponents, we would throw that negative exponent on the bottom, or we throw the term on the bottom, but make the exponent positive. So we get 1 over x to the 357 over 10. Kind of a crazy one, but all right, let's keep going. And I'm trying to watch it as we go through here. So if you have any questions on anything, please put them in the chat, and hopefully I can catch them before I move on. All right, gonna have to keep going back to unread here. We're gonna go on to Alan's question. This is a good one. So this comes from one of the chain rule sections. It's like quiz 7 or quiz 8. I don't remember. So in this one, so real quick, I'm going to go turn off my heat. I'll be right back. But this one, I'll say there's no derivative involved. It's mainly composition of functions and then plugging in 1/2. I'll be right back so the fan's not too loud. I'll be right back. All right, so hopefully that fan will shut off in just a sec. So the first step is to identify G and H, because what we're doing is composing G and H, where if we have G of H of T, that means H will be plugged in wherever we see an X in G. So we're going to basically start with G, and we get E to the something to the 5th. So in place of this X, we are plugging in the function H. So we have E to the cube root of T to the 5th. So kind of a similar situation I would recommend is maybe going ahead and rewriting that exponent as basically the cube root would be T to the 1/3, and then all of that is being raised to the 5th. So then 1/3 times 5, we could call that 5/3. So this is G of H of T, but we also know G of H of T is equal to F of T. So this is F of T, which means if we're finding F of 1/2, we're just going to plug in 1/2 wherever we see T. So it'll be E to the 1/2 raised to the 5/3. So now comes some fun simplifying. I will say, right off the bat, there's no negative. This whole term is positive. There's nothing that could make it negative. So we can eliminate any negative options, leaving us with just B or C. Hopefully, nothing about this would turn the exponent into 1/96. So hopefully by process of elimination, we could get, it narrowed down to B, but let's talk about why B makes sense. E to the 1/2 to the 5/3 would basically be 1 to the 5/3 over 2 to the 5/3. 1 raised to any power, so 1 to the 5/3 is just 1. On the bottom, we have 2 to the 5/3, which we could break up as 2 to the 3/3 times 2 to the 2/3. Because when you break up 5/3, you break it up into basically two exponents that would add to 5/3. 3/3 plus 2/3 is 5/3. So then 3/3 is just 1. So we basically have E to the 1/2 times 2 to the 2/3. All right. I have bots. What is VA Tech? Okay. I was just wondering about the chat there. All right, let's keep it rolling. We are going to check out whatever's next. If they want to pop up. Oh, that's right. All right. Great problem. Let's check it out. Thank you, Rutger, for this problem. Let's jump into it. This is from one of the first few quizzes, and it uses the elasticity formula. Elasticity is N equals percent change in demand. Other times you might use percent change in quantity, all divided by the percent change in price. So let's see what they tell us. They say we got that, we got that, we got that, we got... Oh, you know what, actually? So essentially we could use this, but I think there's almost a shortcut for this one. That's kind of what I'll talk about here. So what we do is really, so I'm just going to keep that there, but also ignore it for this one. I totally forgot. If we're trying to find the answer, we want to take the absolute value of elasticity. In this case, absolute value of negative 1.6 would be positive 1.6, and we identify whether it's elastic or inelastic by comparing it to 1. If it's greater than 1, it is elastic. And I want to say when it's elastic that the basically it has this relationship. When the price is increased, or when the price goes up, revenue goes down, or just the opposite, when the price goes down, revenue goes up. So I believe that should be it. If by chance we had an inelastic elasticity, which means the absolute value of n would be less than 1. So, for example, negative 0.7 or positive 0.9, etc. The price and revenue would go up and down simultaneously. So, if the price goes up, revenue goes up. If the price goes down, revenue goes down. And so this is kind of the shortcut, I suppose. Using this, though, we could have, I guess, calculated that as well. But that should be it. So in this case, what are we looking for? Elastic, price goes up, the revenue goes down. So in other words, we always want the opposite relationship for elastic. To increase revenue, price should be decreased. This one says raised, increased, that would be inelastic. Raised, revenue won't change, that'll never be an answer. To increase, price should increase. Again, that would be another inelastic option. All right. Let's keep it rolling to the next one. All right. Let's see. All right, we have some problems here. 3.31. Yeah, look at that. I think we're back. Okay, so let's jump into this one. So we have a population of fish, and they always give this P population function. So what I'll talk to is basically just the shortcut for this one. Whenever you see this one, no matter what, which fish they're talking about, whatever, anytime you see this problem, the shortcut is taking the two numbers from the denominator, in this case 1 minus 0.56. We're going to perform whatever that operation is between the two of them, and then we will divide that number by the number that's not attached to the e term. So 1 minus 0.56 should be 0.44. And then we would divide that by 1, which is 0.44 or 44%. And that's kind of the shortcut. I'll see if I can find just one more real quick. All right. So same idea with this one. I think I'm just going to do there we go. So I wanted to show an example that had addition in the middle because it's basically the same thing except you would do the actual addition between the two numbers. So in this case, the two numbers in the bottom are 3.64. And in this case, because there's a plus, we will add that to 4. And then we want to divide by the number that's not attached to e. So 4. So in this one, we'd get 7.64 divided by 4. We get 1.91, which would correspond to 191%. So whenever you get these, this is the shortcut that I would recommend. All right, let's see if we can go back to some options here. 434A. So now we're hunting for 4, 3, 4, 8. All right, great question. I could definitely see this one being on the final, so we're going to do a few of them. All right, let's open these up. Starting with this one, this first one here. What we're doing is, or what we're given, is the function f of x, and the goal is to identify f prime of x. The easiest way to do this one is by looking at really the first stretch of f of x and analyzing whether it is increasing or decreasing. So positive slope or negative slope, because where this has a positive slope indicates where f prime should be above the x-axis, because above the x-axis means that f prime is positive. F prime corresponds to the slope, so if the slope is positive, f prime should be positive. So shortcut, if right off the bat it's increasing or has a positive slope, then that means right off the bat we're looking for the color that is above the x-axis. The only one that has that or is above the x-axis off the start is orange. And that's it. I would always look at just the first stretch when you're going through these. So let's do a couple more. Same idea. Right off the start, this one's even nicer because right off the start, it's still barely decreasing. So we're looking for the one that, if we're starting with a negative slope, so it's decreasing, we're looking for the curve that's below the x-axis. Which means, if we look at the start here, the only color that's below off the start is blue. All right, we're going to keep going. Third one. So we're starting increasing or positive slope, so we're looking for the one that is above the x-axis off the start, so orange. Something else to mention, which may play a role later, is this has a positive slope up until, say, about, I don't know, negative 0.1. That's why orange is above the x-axis until about negative 0.1. They should only be, like, for as long as this is increasing, this should be above the x-axis. But once it changes and goes decreasing, so right around negative 0.1, that's where orange should go below the x-axis, and so on. So you want to pay close attention to basically how long it's increasing for, because that'll tell you how long it's above the x-axis, how long it's decreasing for, because that'll tell you how long it's underneath the x-axis. All right, let's keep it rolling. Let's see what other suggestions Angelina had. We had 523A. Okay, let's give that a go. 5, 2, 3. That's 4. 3, 8. All right, another solid question. She had all the good ones. I could definitely see this being on the exam. I'm going to do actually this one and this one, I think. Okay. So we'll just do two of these real quick. Gonna do this one. All right. So for this one, here's the smooth and efficient process I would recommend. We're finding dg over ds, which means the derivative of g, but with respect to s. So what we want to do first is plug second function into the first. Because if g is 1 over r, 1 over r, but r is equal to e to the 2s, then we are going to plug in or substitute e to the 2s in place of r in the function g. So we rewrite g in terms of s. So originally g was in terms of r, but now it's in terms of s once we make that substitution, which means when we find the derivative, it'll be g prime of s, which is equivalent to dg over ds. So in order to find the derivative of this function, it may help to rewrite it. Anytime we see any terms in the denominator, so like 1 over x, 1 over square root of x squared, you always want to rewrite the term up top with the help of negative exponents. All right, so we have our original function, and we're going to take the derivative. So the derivative will require chain rule. So chain rule would be the derivative of the outside. Anytime you're taking the derivative of an e function, that same exact e term with the same exponent should show in your derivative. Then we want to multiply this by the derivative of the inside, which is the derivative of the exponent. So negative 2s, the exponent, has a derivative of negative 2. All right, so now that we have dg over ds, the derivative with respect to s, we're going to plug in s equals 1/2. So now plugging in s equals 1/2, we get e to the negative 2 times 1/2, all times that negative 2. Negative 2 times 1/2 is negative 1 times negative 2. E to the negative 1 is equivalent to 1 over e to the positive 1 times negative 2. And then when we multiply these, negative 2 basically ends up on top. So we have negative 2 over e to the first, or just negative 2 to the e. All right, let's keep rolling. I'm going to do one more of these ones, and then we'll move on. Any questions so far? I'm glad the stream's back up. Doing all right. All right. So, same process here. We always plug the second function into that, whatever that variable is for the first function. So a little bit faster here. Plugging in ln of w in place of x, but then in the function f, x is cubed. So we cube this here. We've plugged ln of w in place of x. So now we take the derivative using chain rule. The outside part is the 3. So we bring that 3 out in front. We always leave the inside the same. We subtract 1 from the exponent to get 2. And then that's just the derivative of the 3 exponent. So then we need to multiply by the derivative of ln of w, which is 1 over w. So this is our f prime. This is df over dw. So the derivative all in terms of w. So then we plug in w equals 2. So we have 3 times ln of 2 squared times, not equals, times 1 over w, or 1 over 2. So hopefully this would be enough to help identify the answer. All they've done is kind of move this squared on top of the ln, so like 3 ln squared of 2, which is equivalent to what's above. And then times 1/2 would basically throw a 2 in the denominator. All right. Hope everyone's doing all right. Hope the stream's all right. Hope it's not too hard to follow along here. I'm doing my best. Thanks for sticking it out with the technical difficulties there. So 5, 4, 3A will be our next one. Great problem. Okay, so for this one, also I'll show a shortcut, and then for this one, I'll try to find the one with Q equals. So we'll get a slight glimpse into 2 different versions of this problem. So I would hope this problem, it wouldn't show up on the final, but I want to say everything we've done so far. I could totally see this. I could see this, honestly. I could see just about every problem we've done so far being on the final. just in terms of like they kind of deal with more general things like derivatives, the graph interpretation stuff. So this one, I would hope it's not on the final, but let's talk through it. So when we see this one, where we have P equals, and we have this like negative Q over some number format, this one has a shortcut. Using doing it the long way, you would use this formula, elasticity equals P over Q times 1 over P prime. And the reason is because we're given a function that is P equals. So we're able to find its derivative, P prime, and then use it in the mix. The shortcut for this one is taking the exponent number, so really just the 10, but keeping the negative. So it'd be like negative 10 over whatever the Q value is. So really, negative 10 over 5 is negative 2. So negative 2, and then it's just determining that 2, the absolute value of negative 2, is greater than 1, which means it is elastic. So that's the shortcut for that one. Let's kind of talk through a somewhat longer one, a similar, same section problem, but different version. This one would use a similar equation that I mentioned a moment ago, but because we're given a Q equals function instead of a P equals function, it would be elasticity equals P over Q times Q prime. All right, so I'll try to do this as fast as possible. It can turn into somewhat of a long problem sometimes. So P is equal to 600. That's not too bad. Q is equal to that function, 4,000 minus 400 times P, which in this case is 600. So we plug in P in place of, actually, you know what? I may keep it P for now, and we'll talk about why. So we're going to keep everything in general terms for the time being, and then plug everything into this before we plug in 600, because something nice may simplify. Q prime is the derivative of this function, so we need Q prime for that part at the end there. We use chain rule. We bring that 2 out in front, leave the inside the same. The exponent goes to 1, so it basically goes away. And then we multiply by the derivative of the inside. 4,000 goes to 0, minus 400p goes to negative 400. This is Q prime. So watch what happens when we plug in for P. Again, I'll just use P, keep everything in general terms for the time being. So we have P over Q, which is 4,000 minus 400p squared, and then we're multiplying this by Q prime, which was this. So Q prime is 2 times 4,000 minus 400p times negative 400. And now what cancels? We have this 4,000 minus 400p squared in the bottom, and we have 1 that's essentially in the top, in the numerator. So we can cancel this whole thing while canceling one of these on the bottom. So that means we're just left with 4,000 minus 400p on the bottom. So now, multiplying everything across the top, we have a p, we have a 2, we have a negative 400. So 2 times negative 400 is negative 800. We keep the p from over here, and we're dividing by 4,000 minus 400p. And now, our p was 600. So we plug in 600 where we see p. And then we will calculate what that is. And again, that should give us the elasticity, the n value. Hopefully I've made no mistakes so far. We're going to pray this works. Negative 800 times 600, all divided by 4,000 minus 400 times 600. And I know the 800's not in the top, but this should still work out. So we get positive 2.03. So 2.03 for our, sorry, I'm a little shaky here, for our n value, for our elasticity. And so we can eliminate the zeros, and 2 absolute value, 2 is greater than 1, so it is elastic. And I wanted to say, now that I think about it, when you get these types, another shortcut might be, I want to say it's always an answer with a 2. Like it's always like 2.03 or 2 on the dot or 2.11, you know what I mean? Like it's never the ones with like 1 or 0. So that might be something to look out for, but I wouldn't rely on it. All right, we're going to keep rolling. 6.3.4. 6.3.4. I think I read that right. I think it was A. Oh, this is a great one. Let's do maybe 1 or 2 of these. Just one should be fine. What's D? Is that a good one? That's one I'd recommend. Graphing in Excel. I would pray you don't get that on the final. That one is not as fun as these ones. So let's talk through a process for this, which might be a little different than what I might have suggested in the past or in the video I made for this. So we're going to try to do this as efficiently as possible. First step is finding f prime, the first derivative, because anytime they're asking about maxes and mins, I recommend finding the first derivative, or usually it requires finding the first derivative. First derivative, we take the derivative of the numerator like usual, but we leave the denominator the same because all these denominators are just constants. All right, so we keep rolling. Minus x squared would go to minus 2x. 45x would go to 45. We leave the 2 on the bottom, and then that constant would go to 0 once we take its derivative. So then what we're doing is plugging and chugging these values into f prime. We're looking for 2 x values that make f prime equal to 0. There are always 2 x values that make f prime equal to 0. So instead of taking the time here to plug and chug these values to get 0, like, time wasted on the stream, I'll just kind of create a little graph for this. So I guess technically you could do a graph of this in Excel. But, generally I would suggest plugging and chugging these on the exam. So minus 2x. So what I'm doing is graphing it and really just looking for the zeros, for the x-intercept. So the x-intercept, the x values that make this function, this f prime function equal to 0, are negative 9 and 5. So negative 9 and 5. So these are the x values that make f prime equal to 0, which means we can eliminate those two. So we know x equals 5 and x equals negative 9 make f prime 0. The question is, which one is actually the minimum? Is it at 5 or negative 9? And now my attempt will be to plug in x equals 5 into the original function, and to plug in x equals negative 9 into the original function. And my hope is that if basically we compare these two numbers, like if one of these values is higher than the other, then that higher number would likely be the max, while the other is the minimum. So in this case, I'll probably plug these into Desmos real quick. Give it a shot. So we have 5. All right, let's give it a go. Let's not waste time. We have basically negative 5 cubed, which should be fine with the negative because it should stay negative, so we don't need to worry about parentheses here, over 6, and then minus 5 squared, and then plus 45 times 5 over 2. That should work regardless, and then minus 1053 over 16. All right, so for this, we get about 0.85. Not a great number, but it's something. 0.83. All right, so now plugging in negative 9. Negative 9, we have, I'll try to do it like this. For this one, I would recommend parentheses. Let's see, we have minus x squared, so minus negative 9 squared, and then plus 45 times negative 9. All right, so for this one, we get, if I've done that right, negative 227.8. All right, so we found that 0.83 is the larger number relative to, negative 227. So the larger number becomes our max, smaller number becomes our minimum. So that's how to basically find which one of these is the minimum. So first derivative, plug and chug these x values to see which two x values, it's always 2, make f prime equal to 0, and then plug these two into the original function to see which one is larger for the max and smaller for the minimum. All right, I think I have a text from somebody to work out this one. Shout out Himani. All right. So this is a great question from the first quiz, I believe, and it's asking about what is a function versus what is not a function. So I guess sort of the shortcut is a function, or I guess a relationship, is not a function if its input value, the value inside the parentheses, if this input value repeats, or if it's repeated for a different c value. So basically, if d is repeated, f is not a function. It's almost like if you have a function f of x. If the x value is repeated, then basically like two different x values giving you two of the same x values giving you two different y values means that that function or that relationship is not a function. So in other words, in this case, d is our input. So we look through our d values and we say, do any of these repeat? So negative 8, negative 17, onward. As long as my eyes don't deceive me, I don't see any repeating d values, which means f should be a function. So then same idea. If we look at g and we see the input is c, we're looking for, does c repeat any values? I see 9 and 9. So that means when you plug 9 into that function, it's giving you negative 8 and negative 10. That would not pass the vertical line test if you were to graph those 2 points. Because you think about it, we have a 9 as the input, the x value, giving us two outputs, negative 10 and negative 8. So they'd be two dots on the same vertical line. Whoops. You get the idea. So 9 and 9 repeat, which means g is not a function. The input value repeats for g, so g is not a function. So only f is a function. All right, hope that helps with that one. What else do we have? I feel like there was still one. Someone had mentioned, I don't think I have it anymore. Someone had asked me to do some, I want to say there were 5.2 problems. And we'll kind of go from there. How's the chat doing? Everyone good? All right, we're good. All right, so let's keep rolling. 5.23a, we did do some of those. That's good. 5.22a, I think we even did one of those. May do another. How about 5.25? This could be a good random chain rule one. So I want to say I've gone through most of the ones people sent me. So, after this, I'll probably just start doing, scrolling through and then picking some important ones that I would think might be on the exam and just work through those. So, all right, let's start with this one. Whenever we see ln to the 5th written like this, I always recommend rewriting it like this, ln of x all raised to the fifth, because visually I think it helps identify the layers of the chain rule. So whenever we're taking a derivative, so we want to find f prime of 0.45, which means we want to find the derivative first, then plug in 0.45. So whenever you're finding a derivative, always ask yourself, will I use chain rule? Will I use product rule? Or will I use quotient rule? Or will I use some combination of the two? All right, so here we rewrite it like this, and then we can take the derivative by bringing the outside 5 to the front, leaving the inside the same, and then multiplying by 1 over x, which is the derivative of the inside. And then it's just a matter of plugging in x equals 0.45 into that x, into that x. All right. So we have 5 times ln of 0.45, I believe it was, raised to the fourth, times 1 over 0.45. So I get 4.5-ish, which is pretty spot on there. All right. Hopefully there's no questions there. I really hope I got all the ones. If I'm missing any questions you sent, I apologize, but I'm doing the best I can. All right. So we're going to go through, may just go through each quiz, and I'll pick, a problem or two that I think is important from each one. Starting at quiz 2, let's see. Have some limit ones, have some of that, some of that. Let's see. What's a good one here? Okay, so what's my idea of the most important one here? I would think, kind of want to do, let's just do one of these and then maybe one other in this first quiz. Let's keep it rolling. Don't want to waste any time. All right, short explanation. If we're given a function and they're asking which value is not in the domain, a value that's not in the domain would be any x value that when plugged into the denominator makes the denominator equal to 0. All right, sorry, I just saw Sam in Matthew's comments. Let's see. Yes, perfect. Okay, yeah. So I'll do those two problems next. I'll do 1.22c, and then we'll jump into some important formulas. All right, so after this one, we'll jump into that. So the denominator equal to 0 is what we're looking for. So we could either plug and chug all these x values into the denominator to see which one gives us the denominator is equal to 0, or we could factor the denominator. So real quick, in order to factor, we need two numbers that multiply to negative 12 but add to positive 1. So those numbers should be negative 3 and positive 4. 4 times negative 3 is negative 12. 4 minus 3 is positive 1. But from each of these x values, once we set, from each of these factors, once we set these factors equal to 0, keep in mind we always get the opposite, in a way, of what we see. So x equals negative 4, x equals positive 3. So we're looking for just one of these to show up here. And keep in mind, they will throw negative 3 in, and we had x minus 3, but x equals positive 3 from that. So they'll always try to do that to kind of trip you up. All right, let's find a 122c? Yeah. All right. Are they in here? I don't know. Let's find it. 122c. I don't think I have any problems. 122c. I'm not sure. I don't think there are any, unless I may just not have any, which would stink. Let's see. Wonder if Sam sent me any. I did those. I'm not sure. Not not sure I have any. Let's see, are there any other 1, 2, 2s? 1, 2, 2. I don't know, I'm struggling. I'm sorry. If you have any 1, 2, 2Cs, go ahead and email them to me if you have an example. Let's jump to what Matthew said. Can you go over important formulas per rectangular plot formula? That's a good one I can include. So Matthew, I mentioned just towards the beginning that in the description there is a Google Doc. I don't know if I can pull that up on here. But in the description in the video here, I've put a lot of important formulas, like a lot of like the basic derivative, rules, and then like profit, revenue, cost, things like that. But for the time being, what I'll do is I'll try to find some problems that relate to, I think the quiz 11 one is good. I'm going to jump into that next. So it was like the max area or the minimum cost problem. So, and then after that, we'll do it was like the yield of trees problem, things like that. So this is from quiz 11, 641C. And the goal is to identify, so I always look at the last question they ask, max area. And so max area, whatever we're finding a max or minimum of, we always want to find the equation for whatever that is. In this case, because they're talking about a rectangular plot, area is always length times width. And so, if we could take the derivative of length times width right off the bat, then we would. But because we have two variables, L and W, we can't do that quite yet. So we have to, basically our goal is to get area in terms of one variable. That's where all the other information about cost comes into play. I'll kind of treat it as explain it as a shortcut for setting up the cost equation. Anytime you're given this problem, we will set up the area equation, which is always the same, length times width, and then the cost equation, which will come from adding these two values and then multiplying it by L, and then these two values, multiplying it by W. 2 plus 3 is 5 times L, plus 3 plus 4 is 7 times W. This is the shortcut of constructing the cost equation for this rectangular plot. If you need a breakdown of like why this makes sense, I think I've put it in the videos I've made for these problems. So if you want, check those out. But I'm trying to be efficient here. So we have cost is equal to this, and then we know that cost is also 650. So we set this cost equation or expression equal to 650. What that allows us to do is what we wanted to do for this equation. We want to represent one of these variables in terms of the other. So once you have this cost equation, what we'll do here is solve for L, or get L by itself. So we'll subtract 7W, and then we'll divide the whole equation by 5. So we'll have 650 minus 7W divided by 5 equals the length. This gives us L in terms of W, which means if we go back to our area, which is length times width, we can substitute this whole expression in place of this length. And that allows us to rewrite the area in terms of W. So that's just our length, and then we still have this W here. So before we find the derivative, so like now that we have area in terms of one variable, the rest of the process will be find A prime, the derivative, set it equal to 0, and then solve for W, and then we'll plug it back in. Once we have W, we'll plug it back into this area in order to get whatever the max area is. All right, so before we find the derivative, I always recommend distributing the W here and here. So 650 minus 7W squared over 5. And that 650 should have a W. Sorry, distributed the W to just the numerator because that's how that works. It's basically W over 1. So we distribute the W to the top, and then the bottom is just 1 times 5. All right. Now finding A prime, we take the derivative of all the numerator terms, and then the 5 is just a constant on the bottom. So any constant on the bottom will just stay as is. 650w goes to 650, and then 7w squared goes to 14w. And then again, we leave all that over 5, and then we set a prime equal to 0. All right, so thank you for putting more problems in the chat. I will definitely go over those after these. So 650 minus 14w equals 0. We could essentially multiply by 5 to the other side, which is nice because we really just have the numerator equal to 0. So we're just going to solve this for w. Divide by 14. 650 over 14. 46.43. So we get w is 46.43. This should be the width for which the area is at a max. So now we plug the plug the width back into the area. That is all in terms of w. That's the most efficient way because we could do the length times width, but then we'd have to find length separately, and it would just take a little bit longer. So we're going to plug in 46.43 into this 650 times w. 650 times 46.43 minus 7w squared. And then this whole thing should be divided by 5. And we get 3017, really about 3018. So plugging into the original area, we get 3018, which should be between 3010 and 3020. So this is one example. I won't work through the next example, the different version, but I will talk through essentially how to set it up. So in this case, because we're looking for minimum cost, we want the cost equation, which again comes from adding these two times L and then adding these two times W. 2 plus 6 is 8, L plus 3 plus 4, 4 plus 3 is 7W. This is the equation we want to find the minimum of, but we can't do that till we have everything in terms of one variable. And we will always use area is length times width. And they tell us that the area now is 8,000. So we set the area equal to 8,000. We solve for L using that. And so now we get L is equal to 8,000 over W. So we plug in 8,000 over W in place of this L in the cost equation. So we rewrite cost like this, all in terms of W, and then the process is the same. We find C prime, we set it equal to 0, and then we solve for W, and then once we have that, we plug that W back into the cost, and that should give us our answer here. So feel free to try that one out whenever. Let's see what I wanted to do next. I do want to use I want to do the tree problem. I think that's also in quiz 11, hopefully. It's like the yield of trees. Yeah. All right. This one's a quick one. Let's talk through it. Essentially a quick one. All right. Okie dokie. All right. So whenever they're asking us to find the maximum yield, we need an equation for whatever that yield is. So then we can take its derivative, set it equal to 0, and solve for the variable. The yield will always be the number of trees times the pounds per tree. So we need expressions representing number of trees and pounds per tree. The number of trees starts at 60. And it only says, we are not removing any planted trees. We are only adding additional trees. So starting at 60, we're not subtracting any, but we are adding trees. So I'll say plus T, where T represents the additional trees. And then the pounds per tree starts at 136. And then it says yield decreases by 1 pound per tree for every additional tree planted. So we subtract 1 times t, since it's 1 for every additional tree planted. All right, this is the setup. So the goal is to find the derivative and set it equal to 0 and solve for t. All right, real quick, I want to distribute or FOIL all this stuff out. I'll leave just 60 times 136. It won't really play a role in this process. We'll distribute the 60 to the minus 1t, so that'll be minus 60t. We'll do t times 136, 136t. T times negative t is negative t squared. We have this constant, I won't even worry about that. Minus 60 plus 136. In other words, 136 minus 60 should be, hopefully, 76t. And then minus t squared. Now that we have the yield, our goal is to find where it's at a max. So that process is always the same. Once we find what we're looking for, we take its derivative. C goes to 0 since it's a constant. 76t goes to 76, and then minus t squared goes to minus 2t. We set that equal to 0. We add the 2t to the other side. We divide by 2, and we get 38 for t. Keep in mind, t is not the total number of trees. It's the additional trees that have been planted. So then how we use this is we look at what they're asking for. Sometimes it says trees. Other times it'll say pounds per tree. Pounds per tree tells us that we want to take this t value and plug it back in to the pounds per tree representation, which is 136 minus 1t. So in other words, 136 minus 1 times t. So 136 minus 38, that'll put us just behind 100 at, I think, 98 pounds per tree. If we have, I don't think I saved it. Here, let's see. If we have this version where they actually ask for trees, if we look in the answer choices, you'll see they say trees. It'll be the same exact setup. So I'll talk through the setup. The yield is going to be the number of trees plus t, so 30 plus t, and then 126 minus 3 per tree, so minus 3t. We would distribute all this, find its derivative, and then once we solve for t, that would be the number of additional trees. Because they're asking for trees, we would plug it back into this parentheses, which represents the number of trees, rather than plugging it into the second parentheses, which is used for when they ask for pounds per tree. I hope this distinction makes sense. Let's keep rolling. So, let's see. And then again, any other important formulas that I suggest will be in the description on that Google Doc. I hope you can check it out. Let me know if there's any difficulty checking it out. So 1.56b is the next one I will do. 1.56b. I do have some of these, so that is a good. All right, look at that. Yeah. So we got that. Great problem. Super quick. Pretty fundamental. I was about to maybe do one of these when I was going through a quiz too, so that's good. All right. The difference between linear power and exponential. Linear grows at a constant rate. It's almost like as long as I guess like in this problem, let's see it like this. So linear has a constant slope, which in terms of this chart, we would look for the function values for which you're adding the same amount each time to get from one number to the next. So like we could assume that f is linear, and we'd say from 4 to 8, we would add 4. And then would we still add 4 to get from 8 to 16? 8 plus 4 is only 12, so that would not get us to 16. So f, for example, cannot be linear. So when we find the one that is linear, we know we're adding 4 to get from 6 to 10, 10 to 14, and 14 to 18. So once we find the one function for which we're adding the same amount each time, we know that one is linear. The trick for exponential is similar, but instead we're looking for the function for which we're multiplying the same number from number to number. So like from 4 to 8 is times 2, so 4 times 2 is 8, 8 times 2, 16, 16 times 2 is 32. Once we find the one that you're multiplying the same amount each time, that will tell us that that one is exponential. And then it only, by process of elimination, leaves this one to be the power function. By definition, what I'll do is define each of them. So like e, the exponential function, will be any function of the form a, some constant raised to the x. Exponential means the x is in the exponent. 3 to the x, e to the x, pi, which is a constant, to the x. These are examples of exponential. X is in the exponent. A power function would be anything of the form f of x equals x to the a. So in power functions, x is the base. X to the third, x to the e, x to the pi. These are all power functions because their base is x. And so hopefully that's some insight in this, which comes up in other versions of basically other problems in quiz 2. And then hopefully this chart method helped you figure out, this one with the chart. I'll just do one more example. Is this the same one? Yeah, I think so. What is the other one? All right. So essentially the same thing. Just to talk through this one as a different example. Plus 1, plus 1, plus 1. We're adding the same amount. So this is the linear. And then this one times 3, times 3. Ba boom, times 3. Ba boom. That's got to be the exponential since we're multiplying by the same amount each time. And then the one that doesn't fit either of those must be our power function. So power, exponential, linear. All right. Let's keep rolling. We have, what are we doing? 1, 2, 3, B. 1, 2, 3, B. I do not have any 1, 2, 3 B's. Hopefully they do not exist. That's not quite it. That's another class, I think. Let's see. Do I have any other 1, 2, 3's that could be related? I have 1, 2, 3 A, so hopefully this would be related. I may work through this just for fun here, because this could be a good fundamental one. I'll find its other half here. Someone had asked this question just recently over email, so this could be helpful to anyone dying to know how to do this. So, quick version here. We want to keep in mind the total amount is 170 and the price of each pizza or bottle of soda. So what we're going to do is find so if we have $170, we're trying to find the graph that represents, the relationship from bottles to pizzas. So we think about if we have 170 total to spend on both, let's imagine we buy 0 pizzas. If we buy 0 pizzas, we don't have to take into account the pizza price. But instead, the question is, how many sodas could we buy if we're not buying any pizzas? Well, if we have $170 to spend on a bunch of sodas that only cost $1.10 each, we divide 170 by 1.1. And that gives us about 154. So what that says is there's 154 sodas when there are 0 pizzas. This is giving us basically the intercept, kind of like the x and y intercept, but it's giving us the soda's axis intercept. So really it's the bottle's intercept. So on the bottle's axis, or basically the y-axis, we're looking for 154. And then likewise, if we're buying 0 sodas, 0 bottles, how many pizzas can we buy? We can buy 170 divided by 13.4 because that's how much the pizzas cost each. So 170 over 13.4, and we get 12.7 basically, so kind of close to 13. So 12.7 should be the pizza's intercept. 12.7-ish pizza's intercept. So that's what we're looking for. It's always the decreasing line. It's never a positive slope. It's never flat. It's always one like this. But for this one, we can't even see where this pizza's intercept is, so can't be that either. All right. Hopefully that makes sense for that one. Hopefully it's similar to the 1.23b. Oh, she said she sent it. Oh, perfect. So while we're on this topic, let's see if we can jump into that. And I see... okay, yeah. So in a way, very similar to the one we went through. Sorry to... let's just go through. Sorry to show your name and image on there if you didn't want that seen, but hope you don't mind. All right. So pulling these up, very similar process. We set, because we have a p-axis and a q-axis, in order to find the q-intercept, we will set the opposite variable equal to 0. P equals 0 plugged in to this equation would give us -5 times 0 minus 4 equals 2q. I want to say someone sent me this recently too. I don't know. Anyway, let's keep going. So -5 times 0 goes to 0. What we're left with is -4 equals 2q. Divide by 2 on both sides gives us a -2. So that tells us that our q-intercept is -2. Likewise, if we plug in q equals 0 into the original, in place of that q, then we will get -5 minus 4 equals 2 times q, in which case if we're plugging in 0, 2 times 0 would be 0. And then we can add the 5p to the right side, divide by 5, and we get -4/5 for p, which means our p-intercept, in other words our y-intercept, should be -4/5. So as we scan through these, I would say starting with the p-intercept, we know p has a negative intercept, which means something like this, where p has a positive intercept, cannot be it. Same deal here. And then between what's left, c has a, I feel like, yeah, I just canceled out the same thing. Sorry, I forgot this was like overlapped. So now between a and b, we're looking for the one that has a -2 q or x-intercept. So -2 looks good there. And then this one has like -0.8 or something. So it can't be that one. So the one that matches both intercepts should be option A. So plug in 0 for p, find the q. Plug in 0 for q, find the p. And that tells us our intercepts on each axis. All right. Awesome work. Thank you again for sending me that. Let's see what Rebecca has here. I think she mentioned these in the chat, but also 151 in the email too. Okay, solid. So let's start with 541. 541A. Got a few of them. Oh, great problem. There are a few different versions of this one. I may do all of them. May do these two. Yeah. All right. Let's give it a go. Do it as fast as we can. Yeah. So I made a few videos for these. I don't know if I ever made one that was like the most efficient way possible. So this is the time to pick up on the most efficient way possible for this problem. All right. We're given average cost and quantity. The goal is to find the rate of change of total cost, which is the derivative of cost, but with respect to price. And then we'll plug in at the very end, p equals 10. This is the fast way. We want to find C and Q, total cost and quantity. We have the quantity, which is 200 minus 5p over 2. And to find cost, we need to use average cost times quantity. There's an equation that says total cost, or cost, is equal to average cost times quantity. We will distribute a Q to this average cost equation. So we're multiplying average cost times quantity, so we're going to distribute a Q here, here, and here. When we do that, we get 5Q squared over 2 plus 150Q over Q plus 10Q. We distribute the Q really only to the numerators of each of these terms. Can we simplify anything? 5Q squared over 2 seems good. 150Q over Q cancels, and we're left with just 150 for the middle term, and then plus 10Q on the end. Those look good. Once we have C and Q, we take their derivatives, and we will multiply these together. So no plugging in, no substituting anything yet. We're taking the derivative of this and that. 5Q squared goes to 10Q. We leave the 2 on the bottom. Anytime we have a constant on the bottom, we can just leave it be. 150 is a constant. Derivative goes to 0. 10Q goes to 10. That's C prime. Now Q prime is the derivative of Q. 200 goes to 0. Minus 5P goes to minus 5 or negative 5. And then the 2, the constant on the bottom, stays unchanged. Over here, we can simplify the 10 divided by 2 to get 5. Now that we have this is really the derivative of total cost, the rate of change of total cost, but really it's with respect to with respect to Q, because there's no P's in here. So the shortcut to this is to plug in P equals 10, but plug it in to Q, because plugging in 10 to Q will give us a Q value for which we can then plug into that and then calculate this, and then that'll be our answer. So plugging in P equals 10 to Q, we get 200 minus 5 times P, 5 times 10, over 2. 200 minus 50 over 2, which is then 200 minus 25, which is 175 equals Q. So, again, because there was no P value in here, in our answer, to plug in 10, we instead find the Q value that corresponds to P equals 10 by plugging in P equals 10 to Q. All right, so now we plug in 175 right there, and then we'll be done. So 5 times 175 plus 10, close that off, times negative 5 halves is what we're looking for. 5 times 175 plus 10, I believe, and then times negative 5 over 2, and we get negative 2212.5. Negative 2212.5, which corresponds to a decreasing rate of 2212.5. That problem is a bear. So hopefully this makes sense. If you have any questions, let me know. Let's keep rolling though. So another version of this problem in a similar way. It's basically the same process, just different formulas. So they ask us to find the rate of change of the revenue with respect to number of employees when n equals 15. So in this same sense, in the last one, since we wanted to find the derivative of cost with respect to P, the derivative of cost required us to find not just C prime, but Q prime as well. In that same sense, if we're finding the rate of change, the derivative of revenue. And we're given a Q equation. We want to find R prime and Q prime. So in order to find R prime and Q prime, we need R first off. So R will be price times quantity. This is our price though. So in the same sense, we're going to start it the same way by distributing a Q to the price to get our revenue. P times Q, 8Q minus 0.01 Q squared. So this is our revenue. So we have 8Q minus 0.01 Q squared. And then our quantity, again, is the one they give us. So just 50 minus N times N, for which I'll go ahead and distribute the N to make it a little easier. 50N minus N squared. Again, now that we have R and Q, that's our starting steps, we want to find R prime and Q prime. R prime is the derivative of this revenue function. So 8Q goes to 8. Negative 0.01 Q squared. We bring out the 2, multiply it by the 0.01, so minus 0.02 Q to the first, or just minus 0.02 Q. And then the quantity is 50N minus N squared, so taking the derivative of that, 50N goes to 50, minus N squared goes to minus 2N. All right. So, how's it coming? All right, we're good. So we have R prime and Q prime. Now we're looking for, this is basically our derivative that we're looking for. But now our goal is to plug in N equals 15. We can plug in 15 for N right here if we'd like. But then same situation as the last one. We can't plug in N equals 15 to Q because that's a Q and not an N. Let's go ahead and calculate this. Actually, no, I'm going to leave that to the side for now. So before we plug in 15, I'm going to figure out what Q is when N equals 15. So we'll plug this in to our Q equation. So 50 times 15 minus N squared, or 15 squared. So let's calculate what this Q value is. Once we have it, we'll plug in Q here while we plug in 15 here. We'll calculate all of it and we'll be done. 50 times 15 minus 15 squared, 525. So that tells us when N equals 15, quantity is 525. We plug in 525 to the first part for Q, and then we plug in N equals 15 wherever we see N. So 50 minus 2 times 15. Once we calculate this, we should have our answer. 8 minus 0.02 times 525, and then times 50 minus 2 times 15. And we get negative 50 for our final answer. So R prime with respect to N equals 15. With respect to N, when N equals 15, is negative 50, yeah. So looking at our answers, it's decreasing at a rate of 50 per employee. That one is also a bear. If these are intimidating, keep in mind the odds of getting these on the final are hopefully very, very slim, and if they do, it'll show up once. One problem is it's okay to miss. These suck. I wouldn't waste your energy on learning them if they seem scary right now. So going back to Rebecca's questions, 322A. Let's see if I have some of those. 322A. I have a few of them. These are great problems. I could totally see one of these being on the exam. I'll do these all the exact same. Yeah, I'm not going to do multiple since they're all pretty much the same exact process. But I would recommend maybe going over a couple other problems that mention interest compounded continuously. The key word is continuous. Continuous interest, compounded interest continuously, or sometimes they'll say continuous exponential decay. anytime you see the word continuous, this is from quiz 4, I believe. Anytime you see continuous, you always use PERT. A equals PE to the RT. A is the amount of money at time T. In other words, like the amount of your investment at time T at a certain time. P is your initial or your principal investment. And then R is the rate. So if they said like 4%, you wouldn't use 4, you'd use 0.04. And then T is time in years. This is a great question. I can totally see this on the final, so let's get into it. We're going to use this, again, because they say continuous. We are going to use this first pair of information and plug them in to this equation. So it's basically saying at time 7 years, the amount of the investment is $619.45. So we'll plug in T equals 7 and A equals 619. So I'm going to move this stuff over a little bit. Whoops. All right. So I'm going to move this stuff over. We're going to set up one equation, and then we'll set up the second equation. So honestly, I may do the second one first, and we'll talk about why. So they give us another pair of information, which is when T is 14, A is 737.92. We're going to plug these values in first to this equation. So A, 737.92, equals P, we do not know, E to the R times T, which is 14. And I will say, how much did your parents put into the certificate at birth? What we're looking for is the initial investment. What we're looking for is P. So first step is setting up that equation and then setting up, that same equation, but with this pair of information plugged in. So we'll say 619.45 equals P, E to the R times 7 in this case. So the reason I wanted to do the larger values on top is because once we set these up, we will divide the left side by the left side and the right side by the right side. We're essentially dividing one equation by another. So what that'll end up is, how that'll end up is these numbers, 737 divided by 619 on the left side. Let's go ahead and calculate that. 737.92 divided by 619. 45. So we get about 1.191. 1.191 on the left. And then on the right side, let's talk about what happens. We have P times E to the 14R, basically. R times 14. On the bottom, we have P times E to the 7R. P and P on top and bottom will cancel. And then the question is E to the 14R divided by E to the 7R. How will that simplify? When we have the same base, different exponents, divided by one another, we subtract their exponents. So 14R minus 7R is 7R. All right, so now the goal is to solve this equation for R. To eliminate E and aim towards getting R by itself, we need to take the ln of both sides, the natural log. Ln and E will cancel, leaving us with just 7R on the right side. On the left side, we will have ln of that number. I'll just leave it like that for now before I calculate it. Ln of 1.191. And then to get R by itself, we will divide by 7. So we're going to calculate R. Ln of 1.191. Since I have the decimal right above, I'll type in a few more just to be exact. 1.19125. And then we'll divide that by 7. And we get a nice 0.025 as our R value. Now that we have R, we'll go back to one of these initial equations. So either the top one or the bottom one. I guess I'll use the bottom one here. It does not matter. And so this was our first step. This is our second step. Once we have R, we're plugging in R into where we see R. So 619 equals P e to the 7 times R, which is 7 times 0.025. And then we have, so we'll do, all right, so what we'll do is try to figure out this E value first. E to the 7 times 0.025 should just be a number. So E raised to the 7 times 0.025 should give us 1.19. So what we have is 619.45 equals P times the value we just got, 1.19. And so we're solving for P. Keep in mind, we're looking for how much did they put into your certificate at birth, which is our initial investment. So we divide by 1.19 to get P by itself. So 6.1945. 6.1945. Did I say that right? What am I saying? 619.45. I think I said, I don't know. Just on a roll here. I don't know what's happening. Let's see. 1.19. And we get approximately 520 for P. So our initial investment should be 520. All right. Hopefully that makes some sense. Again, I may do one more problem with PERT with A equals P e to the RT, just because I could totally see it, maybe 1 or 2 problems on the exam using that equation. But before I do so, I think there was still a 151 to look into. 1.5.1. I have a few. Oh, good. So I did one of these at the very start, but let's do another just to run through it. This looks fun. All right. All right. So starting from the top, it's basically the goal of this problem is to simplify everything using exponent rules. So what we'll do is start with the numerator, and anytime you have a certain root, keep in mind you can rewrite it as, like if it's a square root, that 2 is going to go into the denominator of your exponent. Hopefully that makes sense. We have the we have the x to the 2, but then divided by that 2. So it'll be x to the 2 over 2 for the first part. And then we have x to the 2 over 6. Again, anytime you have the 6th root, that 6 will go on the bottom. So then repeating that process, for the bottom, we have x to the 3 over 9. Can we simplify here? X to the 2 over 2 is x to the first, which is really just x. Then we have x to the 1/3, 2 over 6. So 2/6 reduces to 1/3. Then on the bottom we have x to the 3 over 9, which is also 1/3. So then from here, taking a look, kind of from a broad standpoint, we have an x to the 1/3 on top and 1 on the bottom. We are left with just x. I don't know if that one was too easy, but I will say with the one I did at the very beginning, hopefully that's still saved. I'm not sure. But in this one, this one might be on the final, but if it is, it's one problem. But I doubt it based on what's going, what the other important stuff is. So I'm hoping this is helpful enough. But again, it really just uses exponent rules. The biggest things to look out for are if you have x to the a over x to the b, that turns into x to the a minus b. Anytime you have, say, x squared raised to the 4th, we don't add them in this case. We do multiplication of 2 times 4. If instead we had x squared times x to the 4th, that's when we add their exponents and make it x to the 6th, and then kind of the other version of This division one is when we multiply them. So if we have x to the a times x to the b, that's equivalent to x to the a plus b. We add their exponents. So hopefully that helps well enough. And then again with the roots, if you have the nth root of anything, we rewrite it as x to the 1 over n. And then if it's x cubed under the nth root, then it's x to the 3 over n, etc. So, all right, let's keep rolling. Jax Lee C said 521A. Kind of sounds familiar. Let's see if we've gone through it today. 5, 2, 1, 8. We have not gone through this one, so let's talk through this. These ones always look super complicated, but I promise they're not too bad. This is one of the only problems I think in whichever quiz this is from. I can't remember. Whichever like the chain rule one is, where we don't have to take a derivative. It is solely the idea that we are given a function f, a function g, and we need to find f of g of x. F of g of x means that whatever function is on the inside of the parentheses will be our inside function. So we are going to take the function g of x, 9 over 2 to the x, and plug it in to this x in the function f. So whichever function is on the outside, f, means that we're basically going to have that function. So I'm going to write out the function f, but leave a big parentheses where we see x. So it's cube root of 2 over 1 minus x, so we'll leave big parentheses where the x is, and then a plus 2. Okay, so then we're plugging in g of x, 9 over 2 to the x, in place of this x. So 9 over 2 to the x. And all we're doing is looking for that answer. As we scan through these options, do we see a close answer? That should match that pretty spot on. And there should be no crazy tricks with these, no crazy rewritings. It's usually a direct answer of composing those two functions. So real quick, we'll do one more, because sometimes, I guess a tip is make sure, to recognize where they swap it up. They switch it up on you. In the last one, we had f of g. In this one, they have g of f. So we start with the function g, which is 2 to the x. But in place of the x, we leave a big parentheses for which we will plug in f. So 3 over 1 minus x minus 3, all to the 4th. All right. Do we see the answer? Big 2 on the bottom, big F in the exponent. It's looking like C. All right, let's keep rolling. What do we have? Any more emails from non-spam companies here? All right, nothing that I see, so I'll go back to kind of running through important problems that I could see being on the exam. I think this is a great one. I would like to go through this one. Again, if you have any problems or pictures of problems, screenshots, whatever, feel free to send those my way while I'm still on for the next 20 or so minutes. And again, this video will be posted to YouTube after the session is over. So, if you need to head out, no worries. In this one, they give us some information about supply and demand. And they give us some information for each one, and they mention that supply and demand can be represented as linear functions. And then they ask what price should be, what should the price of donuts be so that there's neither a surplus nor a shortage, which means we're going to set up a linear function, y equals mx plus b, for demand, and then a separate one for supply, and then we're going to set those two functions equal to one another and solve for x at the very end. So let's break it down. Demand. They tell us that 350 donuts are sold when the donuts are free, and then demand drops to 250 when the price is 25 cents. We want to use the format price, comma, donuts in terms of our X and Y value. So what they're giving us is 2 ordered pairs for demand and 2 separate ordered pairs for supply. All right. So when the price is 0, when they're free, they're giving away 350 donuts. So 0 is our price, 350 is our amount of donuts. Likewise, when the price is 25 cents, in this case, we don't have to use 0.25, but you could if you wanted to. But I'll always keep it in units of cents. So we can do 25, comma, 250. And just for fun, let's go ahead and identify the supply ordered pairs. 150 donuts free means that for supply, we have 0, comma, 150, and then 50, and 200. So 50 cents corresponds to 200. So then from these ordered pairs, we should be able to find the slope and the y-intercept. The slope between 2 points is y2 minus y1. So I'll do 250 minus 350 over x2 minus x1, which is 25 minus 0. On top, we get negative 100. On bottom, we get 25. Divide those. Think about dollars and quarters. 100, negative 100 divided by 25 is negative 4. And then the shortcut for finding B, our y-intercept, will come from the ordered pair that has x equals 0. Because when x equals 0, whatever that y value is our y-intercept. So we'll look just at the ordered pair with x equals 0 to tell us that our b value is 350 in this case. So then, with y equals mx plus b, we have our m, we have our b, so y is equal to negative 4x plus 350. In this case, we repeat the process for supplies. So m is equal to y2 minus y1, 200 minus 150, over x2 minus x1. So we get positive 50 over positive 50, which is 1 for our slope. And then again, the b value comes from the y value for the ordered pair that has an x value of 0. So just 150. All right. So then the equation here is just 1x, or x plus 150 equals y. We have our two equations, linear equations for demand and supply. Since we want the price, for which there's neither a surplus nor shortage, we set them equal to one another, and we solve for x. We want to add the 4x, so plus 4x here, gets rid of it there, we get 5x. Simultaneously, I'll subtract the 150 from both sides. 350 minus 150 gives us 200. Divided by 5, we get 40 is equal to x. So 40 cents per donut would be our answer. I thought that was a good problem, and it uses a lot of fundamental function ideas, and it's a nice little kind of business-related problem. All right. Let's see. Quiz 4. What we got? So in this quiz, there were 4 equations, 4 formulas that were pretty important. I think I mentioned earlier I wanted to do one more that dealt with continuous something. So like the one that would use the continuous interest compounded or continuous exponential decay. So I could see something like this also being on the final. So let's talk through it. Keyword is continuous. Anytime you see that from this earlier section, that tells us to use A equals PE to the RT. And I've written out the variables earlier, but we'll talk through what they mean as we go through it. So they say, or this says, they invested $2,000 at the very beginning. So the initial investment is our P, or our principal. Then it says 5 years after the initial investment. So when T equals 5, specifically, the value of the stock is $19.20, which means at t equals 5, the amount, the a value, is 1920. We can almost see this as like an x and y value, like x and y pair that correspond to one another. So what we're going to use is these three values and plug them into the function to solve for r. Once we do that, then we'll address the final question they're asking. Solve for r. So we're going to plug in 1924a, 2000 for p. We have e to the r times t, which is 5. Our goal is to solve for r from this equation. We start by dividing by 2000. R times 5 is just 5 times r. And then I'm going to do 1920 divided by 2000. So we get 0.96. So kind of just dealing with this equation now. We want to get r by itself eventually. Anytime we need to eliminate an e, we take the natural log of both sides. ln and e will cancel, leaving us with just the 5r exponent. We have ln of 0.96, so to get r by itself, we divide by 5. ln of 0.96 over 5 equals. Let's see, we get negative 0.0082. Negative 0.0082. Let me double check that just in case. So I think we're good. Yeah. So this is our r value. Pretty fun. This is our rate that the amount is going down. So exponential decay means the rate should be negative. So then they ask, so if they say that today is 5 years after the initial, then they say, what would the investment be worth 3.5 years from today? Well, if today is 5 years since the initial, and then they ask about 3.5 years from today, then the t value they're concerned with is not 3.5, but 3.5 plus the 5 years that have already gone by. In other words, they're asking about what would the amount of the stock be worth, or amount of the investment be worth 8.5 years since the initial. So now we have everything to plug in that we need to. So A is what we're finding. P is still the initial 2,000. We have E to the R, which we have now, which is negative 0.0082 times the T value, which we're concerned with, which is 8.5. So now we just plug in all this to find an A value. 2,000 e to the negative 0.0082, I think it was, times the 8.5. Let me double check. All right, I think we're good. And then that gives us about 1865. Point like 3.5 as our amount after 8.5 years. So 1865.91 is close enough. I think if I had used more decimals in the R value, I would have gotten a more exact answer. But nonetheless, that should be close enough to find our correct answer here. All right. If there's no more questions on the chat, I don't think there's any more in the email. Solid. All right, let's keep rolling through some. We may have time for a couple more. Let's see what I can find that's kind of important, in my opinion. Let's do more graph ones. I feel like we didn't do enough graph ones. I could see this one. Do some kind of quick ones. That one's a good one. Even though it's a chart one, it's a good little fundamental one. All right. Won't waste any time. Let's keep going. All right. Quickly, which of the following is a graph of a function that's not differentiable, meaning the derivative does not exist? In other words, the slope does not exist at x equals 1. So we look about x equals 1, and we're looking for something peculiar, particularly that, in this case, at 1, this function has a sharp corner. Anytime we have a function that has a sharp corner, right at this corner, we cannot find a slope. In other words, the derivative does not exist. So no slope does not mean a zero slope, but it means the slope does not exist, which means it is not differentiable. So we are looking for, I've heard in the past people looking for like x-intercepts at 1, so like that, or yeah, I guess that's pretty much it. X-intercepts like that. That's not necessarily what tells us what's not differentiable. We are just looking for which graph has the sharp corner at x equals 1. So that would have to be 4 in this case. All right, nice little fundamental one. All right, let's jump to this one. I always look at the last question first, usually I guess. Usually look at the last question, or what they're asking for first, in order to guide the process. Find the marginal cost at 79. Marginal, big tidbit here is whenever you see marginal in this business calc course, it usually means find the derivative. In other words, the rate of change of whatever they're talking about. Marginal cost would mean estimating the derivative of cost at 79. When we're given a table of values like this, and we're only given cost values, in order to estimate the derivative, or the rate of change, or the slope of cost at 79, we always want to use the values left and right of 79. Top values correspond to x values, and the bottom sort of correspond to y values. And I only say that because to find the slope between 2 points, the rate of change between 2 points, we want to use y2 minus y1 over x2 minus x1. The slope between these 2 points will give a good estimate for the slope right in the middle. In other words, the slope or the rate of change at 79. Let's give it a shot real quick. We have 1090 minus 1,000, all divided by 83 minus 75. So on top we get 90. On bottom we get, I think that's 8. Yeah. So 90 over 8. It's about 11.25. And that's kind of the quick way to get your answer. All right. Did I pull one more? Oh, yes. Okay, good. So this one I could totally see on the final. They say function is represented, so original function f of x, list points a, b, and c in order of instantaneous rate of change. That just means slope or derivative, but slope is better. In order of decreasing slope of these points. In other words, we want to identify essentially the slope of each of these. Not the number, but really if it's positive or negative. We want to order these from the most positive slope to the most negative slope. So we start with which of these points are on a positive slope. We have C is on a very positive slope. We have B is on a positive slope, but a little less steep. And then A is just barely on a negative slope there. So, from most positive to most negative would be C, B, and A. The steeper the slope is, the higher it is in that direction. In other words, since C is a more positive slope than B, then C is, more positive. Like, it comes first. But say we had a point here, say D. D is more negative of a slope than A because A is a little more flat. And so if we had to order all 4 of these, D would come last because it's the most negative out of all of these. So just an insight into that. Let's see if we can find another good problem that I could totally see on the exam. Blah, blah, blah. I could kind of see this. It's a solid one. Simple, but it really helps to know the fundamentals of it. Anytime we see x on the bottom or underneath some sort of root, we always want to rewrite that function first before we take its derivative. Cube root of x is x to the 1/3, which means 1 over cube root of x is equal to 1 over x to the 1/3. Anytime we see x on the bottom, we want to rewrite it on top with the help of negative exponents. So rewriting this entire function before we take its derivative is x to the negative 1/3. So then h prime, its derivative, will then use the power rule. So we'll bring down the exponent, leave the x, and subtract 1 from negative 1/3. The trick to subtract 1 from negative 1/3, or really from any fraction, is to take the top number, negative 1, minus the bottom number, minus 3. Negative 1 minus 3 is negative 4, and then since it was negative 1/3 to begin with, we keep the 3 on the bottom. So top minus bottom over the bottom. So we get this as our derivative, which is solid. So then, just to kind of work out the rest, negative 1 stays on top. We can throw this x to the positive 4/3 back on the bottom, since it was negative, exponent up top. And then the last step is to plug in 27. And just to kind of talk through working this out by hand, you could, of course, plug it into a calculator and then figure out which one of these fractions matches the decimal. But just real quick, 27 to the 1/3, so taking care of this 3 first. In other words, the cube root of 27 is 3, and then raising that 3 to the 4th would basically give us, negative 1 over 3 to the 5th. Once we incorporate this 3, 1 over 3 to the 5th, I don't think I truly know this off the top of my head without looking at the answer, but 3 to the 5th is equal to 243. So we have negative 1 over 243. All right, let's see if we can do maybe one more really, really good one. And if it's a little long and goes over 12 o'clock, that's fine. With respect to all the chain rule stuff, I would hopefully not worry about it too much, because those were just crazy problems. I would love to do this one. This is a solid one, so I may do this one and maybe one other, maybe kind of word problem type thing I could see on the final. So this one's very easy, but I can totally see it on the final. So they give us some information about cows. In the other example, they mentioned schools and students and stuff. Same process for both of them. They say use the product rule, which I'll call A times B plus A times B prime, which has 4 values that are multiplied and added together. And they happen to give us 4 values. It's just a matter of basically identifying them and labeling them. So the first 2 they give us are 459. Then they say that number of cows is decreasing at a rate of 14. That rate tells us it's a derivative, A prime, and decreasing tells us it's a negative 14. Likewise, B and B prime. B would be the regular amount of gallons, 1250, and then they say it's increasing at 44 gallons per year, or gallons per cow per year. So B prime is just 44. With these 4 values, we plug these into this. So negative 14 times 1250 plus 459 times 44. Negative 14 times 1250 plus 44 times 459. So we get 2696. Did I do that right? Yeah. So 2696. Come on, Carter. There you go. So 2696 increasing because it is a positive. So not the decreasing version because it's not negative. So D would be our answer in this one. Let's see if we can do one more. Something with a shortcut or something fundamental. What we got in 9? Yeah, let's do a graph one. I think that'd be helpful. Okay. Fundamental. Let's do this one. I think this is a good one. No, it's too weird. I want to do that, but a different version. Like this, maybe. Yeah. Let's do this one. All right. So in this problem, we're given f of x. And so whenever they mention relative max, relative min, they are literally talking about high points for a max and low points for a min. So, and then another tidbit is any of the points that are in between maxes or mins will really be inflection points every time. So you can just assume that any of these in-between points are inflection points. So now going through our statements, B is an inflection point. That matches the one we just labeled. B is a relative max. Can't be true because it's an inflection point. C is a relative minimum, which is true based on that. So 1 and 3 would be our answers there. I think I'm going to call it there even. Evan in the chat said, is there anything you would say as advice for taking the final? Certain things that would really be important to remember. I've included what I think is important in the Google Doc in the description of this video. Hopefully you can see it. Hopefully you can access it. It has derivatives, formulas. So I would highly recommend knowing product rule for when you have two x terms multiplied together, really sum A times sum B. I would know quotient rule. So some x terms divided by other x terms is when you would use it. And I would understand like minor chain rule things. There were a bunch of crazy chain rule problems they had you doing in one quiz. I hope they don't throw those on the final. I would expect easier ones where you have like different layered functions like this. So e to the 2x, for example, would have a derivative of just e to the 2x times 2. So 2 from the derivative of 2x, and then e to the something always has the derivative of e to the something. So it stays the same. So like basic chain rule, I would suggest knowing. So derivative-wise, kind of those basics. Business-wise, I guess, kind of on the same level of importance as derivatives. I would understand, or I would know the formulas for profit, revenue, price times quantity. Again, profit was revenue minus cost. Cost being variable cost times quantity plus fixed cost. All these like very, very important ones. And then kind of then down the line, I would say elasticity, understand some of the basics with that. When to know something is, or how to know something is elastic versus inelastic. So like absolute value of n being greater than 1 or less than 1. And I included a whole bunch of other tips in the Google Doc, so feel free to reference that. It may not be complete. I was just like throwing it all together this morning. But hopefully it helps at least a little bit. I think I'm going to call it there. If you have any questions, before you take your final, feel free to email me and I'll try to help, as much as I can. If I've helped you this semester, let's see, what are the comments here? We got, thank you for teaching the whole VT math department. Happy to help. I'm happy I could help out hundreds of students this semester. It felt really good. It was a different, challenge trying to put all these videos up, but it was pretty rewarding. Y'all have been nothing but supportive. I love all of y'all. Really, it's a good mood booster this semester, getting all the appreciation and praise and stuff. And so I'm happy I could do it. Happy I could post some videos. If I was helpful to you, and you've already made a donation to my Venmo, thank you very much. If you haven't, my Venmo is at Carter D with 3 E's. And if it asks you to type in the last 4 digits of my number, that is 6910. If you can make a donation, I'd greatly appreciate it. If not, that's totally fine. All the comments and support and emails and other donations, everything's been nothing but appreciated. Thanks so much. Hope your final for this class goes smoothly, as well as any others you might have. All right, I think I'm going to call it. See y'all later, and thanks again.